Assalamualaikum and selamat sejahtera. Today, my group and I will be presenting on the road safety audit that we have conducted over the past 4 weeks. Before we begin, these are our group members that have contributed greatly in our case study. Me, myself, Fakir Halim. Next, we have Muhammad Ridwan Adli. Next, we have Muhammad Rafif Takiuddin. And finally, we have Muhammad Izlan Fahmi. So, for the introduction, road accidents are a major safety concern on campus. Road safety audits, also known as RSA, identify potential hazards and suggest ways to mitigate them. This study evaluates a selected road in UiTM Shah Alam. The audit also focuses on vehicle speed behavior and traffic volume characteristics. So, the objective are to conduct safety audit at UiTM Shah Alam, to determine traffic volume and peak flow condition, to measure speed of vehicle at selected location. We need also to identify the safety hazard associated with high speed and high traffic demand at the conflict area. By proposing suitable traffic control measure, we can improve the safety of students within the campus. So, for the study location that my group has selected to conduct the road safety audit on is UiTM Shah Alam Main Gate. So, the road here acts as a T-junction and serves as a major entry and exit point to the campus. This location experiences high vehicle interaction due to the merging and turning movement, especially during peak hours. The presence of the main road with relatively high speed and also traffic volume creates a conflict area, making this junction a critical location for evaluating speed behavior and also safety performance for the campus. Next, after careful evaluation of the T-junction at UiTM Shah Alam Main Gate, there are two most common safety issues, which are the speed of the vehicle and also traffic congestion.
So, the first study that my group and I have conducted is a traffic volume study. This is to check for traffic congestion. So, let's take a look at the apparatus needed for the traffic volume study. First, we will need a multi-tally counter that classifies the vehicle types. We would need a vehicle observation sheet. We will also need a clipboard, a safety vest, a pen, and also a stopwatch. Next, we move on to how we actually conducted the traffic volume study, also known as the methodology. So first, the selected T-junction was divided into 6 different traffic movement directions. Each group member was assigned 2 directions to ensure continuous and also accurate data collection. The traffic volume was recorded over a total time duration of 1 hour with 15-minute intervals. The vehicle types were also divided by using the manual tally counter. All collected data were then tabulated and analyzed to generate traffic volume and speed-related graphs for further evaluation. Moving on, we have the results and data analysis section. The first table of hourly volume by direction shows that direction 3 has the highest vehicles per hour with 300 vehicles. This makes it the most dominant part of the most dominant direction at the T-junction. Also, in that 1 hour time duration, it is observed that the total vehicles added up from direction 1 all the way to 6 is 1,240 vehicles per hour. Next, the 15-minute traffic volume distribution table indicates that the 15 to 30-minute time interval experienced peak flow of 344 vehicles. Based on this, we can use the formula and we will get the peak hour volume, also known as PHV, to be estimated around 1,376 vehicles per hour. This indicates high traffic demand during peak times, and also these findings highlight potential for congestion and also increased conflict at the T-junction. So from the tables previously, we can generate our graphs. So the bar chart shows that direction 3 has the highest hourly traffic volume. This confirms that it was the dominant movement at the T-junction. Next, the line graph next to it indicates the peak traffic flow occurs during the 15 to 13-minute time interval. This highlights the peak period congestion at the study location. Last but not least, we are able to tabulate and also graph for hourly PCU by direction using the urban standards. So from the graph here and also the table, it is observed that direction 3 has the highest PCU value of 286.75 vehicles per hour. This just shows that direction 3 is the most critical direction of the T-junction and also highlights the need to implement traffic control measures and also safety measures along this particular direction.
Okay. For this spot speed study, on our two selected major road, so the apparatus that we need is first automatic method, which is radar gun, data sheet, clipboard, and safety vest. For manual method, measuring wheel, stopwatch, safety vest, data sheet, and clipboard. For our methodology, the radar gun meter was pointed on the targeted road to illuminate the road. The radar gun meter was made as a direct line with oncoming traffic as possible. The vehicle speed was observed for a duration of 1 hour. So for manual method, there are two reference points were selected as start and end point with a distance of 50 meters apart. Two stations observed at start and end point, and observers at start and end are the remarks of 50 meters distance, as the stopwatch will start counting times between 2 points. So this slide shows the result and data analysis of spot speed measurements using both manual and automatic methods. On the left, the histogram compares the frequency distribution of vehicle speeds for both methods. We can see that most vehicles fall within the 20 to 40 km per hour range. The automatic method recorded a higher number of vehicles in each speed class compared to the manual method, indicating the automatic system is more consistent in capturing vehicle speeds. On the right, the cumulative frequency distribution curve is shown. This graph illustrates the cumulative percentage of vehicle against speed. From the curve, we can observe that the 85th percentile speed is approximately 40 km per hour for both methods. This indicates that 85% of vehicles are traveling at or below this speed. Overall, both methods show similar trend, but automatic method provides more detailed and reliable data, making it more suitable for traffic speed analysis and engineering evaluation. So this slide presents the result and data analysis based on the percentile speed values obtained from both automatic and manual methods. From the table, we can observe the comparison between speeds at different percentiles. At P15, the automatic method recorded is 90 km per hour, while the manual method recorded 17 km per hour. At P50, which represents the median speed, the values are 29 km per hour for automatic and 30 km per hour for manual, showing very close agreement between both methods. For higher speeds, which is P85 value, which is commonly used in traffic engineering analysis, which is 38 km per hour for automatic and 36 km per hour for manual. Meanwhile, the P1998 value shows 45 km per hour for automatic and 40 km per hour for manual, indicating slightly higher maximum speeds captured by the automatic method. Overall, the results show that both methods produce similar trends, but the automatic method generally records slightly higher speeds and provides more consistent data. This confirms that the automatic method is reliable and suitable for speed analysis. We are going for the discussion. The impacts on traffic on society. Traffic has both positive and negative impacts on society. It helps economic development by allowing people and goods to move easily to workplaces, schools, hospitals, and markets. However, heavy traffic causes congestion, delays, stress, and loss of productivity. It also leads to air and noise pollution, health problems, and road accidents that result in injuries and loss of life. Overall, while traffic is poor, while traffic is important for daily activities and development, poor traffic management creates serious social, economic, and environmental problems. For traffic control and management system, it is regulate the movement of vehicles and pedestrians to promote safety and maintain efficient flow on roadways. These systems encompass traffic lights, road signs, signals, speed limits, surveillance cameras, and intelligent transport systems that monitor and manage traffic conditions. By reducing congestion, preventing accidents, saving travel time, and enhancing overall road efficiency, these systems are particularly vital in densely populated urban environments. Sustainable solution for road traffic. It is identified through spot speed and traffic volume studies aimed to enhance safety and ease congestion. These measures include strict speed limit enforcement, the use of traffic calming features such as speed bumps, speed humps, and rumble strips, better road design, and the installation of traffic signals or roundabouts to handle heavy traffic. Promoting public transportation, car sharing, and non-motorized travel like walking and cycling further helps the lower traffic levels. With effective planning and traffic management, sustainable transport solutions can lead to safer and more efficient.
The future of road mobility, the development of safer, more intelligent and more effective transportation system in the main goal of the future of road mobility, which is based on spot speed studies and traffic volume analysis. Authorities can create better roads, establish sensible speed restrictions, and efficiently handle congestion by having a better gap of vehicle speeds and traffic flow. In the future, fewer accidents, less traffic, and seamless vehicle movement will be ensured by the employment of intelligent traffic system, enhanced public transportation, and sustainable travel alternative. Recommendation to prevent from speeding. First is paint road markings such as low or put speed limit value on the road surface. Next is install speed bumps to force vehicles to slow down. Next is provide clear low speed limit signs of 20 to 30 km per hour at all campus entrances. Lastly is add rumble strip before junctions, crossings and sharp bends to alert drivers and reduce speed. Next is recommendation prevent from traffic volume. First is provide shuttle bus service between campus to reduce vehicle use. Second is implement one-way road system to reduce conflicts and congestion. Next is improve public transport connectivity to and from the campus. Lastly is manage parking properly to avoid illegal parking that blocks traffic flow. Conclusion. In conclusion, controlling speed limit and managing traffic volume are essential to ensure road safety and smooth traffic flow, especially in areas with high pedestrian activity such as university. As a safe speed increases the risk and severity of accidents, while high traffic volume leads to congestion, delays and unsafe road conditions. By implementing appropriate speed control measures, improving road design, enforcing traffic rules and reducing private vehicle usage, a safer and more efficient traffic environment can be achieved. These measures help protect road users, enhance mobility and improve the overall quality of the road system.